You ever hit the power button and just stop and think? In those, 5 or 10 seconds before you see a login screen, there is this whole hidden world, this incredible, perfectly choreographed dance happening inside your machine. So today, we're going to pull back the curtain and see exactly how a silent box of metal and plastic becomes a fully fledged Linux system.
You know, it feels like it just happens instantly, but it's not magic. It's actually a multi-stage relay race. Every single runner has one specific job to do, and they've got to pass that baton to the next one flawlessly. So get ready, because we're going to follow that baton from the very first spark of electricity all the way across the finish line.
All right, here's our game plan. Think of this as the map of the racetrack. We'll kick things off with the hardware wake-up, then we'll watch that first big handoff to the bootloader. After that, we'll see the kernel itself take control, and then meet the final boss of the whole operation, systemd. And finally, the most useful part, what to do when one of these runners trips up.
And we're off. The first runner bursting out of the starting blocks is your system's firmware. You've probably heard of it. It's either the old-school BIOS or the much more common UEFI. Its first job is to basically shout, "Wake up!" and make sure all the hardware is actually ready to run.
Think of this part as the system doing its morning stretches. The post is just a basic health check. Is the CPU there? Check. Is the RAM responding? Check. If any of these fundamental checks fail, the race is over before it even begins. And if you've ever heard a computer make a weird series of beeps on startup, well, that's its way of telling you exactly which part didn't pass the warm-up.
Now, it's worth knowing that not all of these first runners are built the same. BIOS is kind of like the old veteran of the team. It gets the job done, but it's got some limitations. UEFI, on the other hand, is the modern high-tech athlete. It's way faster, it can handle massive hard drives, and, most importantly, it has security features like Secure Boot built right in, which helps stop nasty stuff from messing with your computer before it even starts. Pretty much any modern machine is going to be running UEFI.
Okay, so the hardware all checks out. The firmware's part of the race is done. Now it's time for the first really critical moment, the handoff. We are passing the baton from the physical world of circuits and silicon to the abstract world of pure software.
So how does that actually work? Well, the firmware scans your drives, finds the one it's supposed to boot from, and reads a teeny tiny piece of data from the very beginning, just 512 bytes. On older systems, that's called the master boot record, or MBR. You can think of it like a little sticky note with just one instruction written on it. Go find the real bootloader and wake it up. And for pretty much every Linux system out there, that real bootloader is GRUB. So GRUB is our second runner, and this one's a big deal. If you dual boot with Windows or another OS, GRUB is the program that gives you that menu to choose. But its most important job is to go find the Linux kernel file on your hard drive, scoop it up, and load it straight into your system's RAM. And what you're looking at here, this is a little peek into GRUB's playbook. This is from its configuration file. That Linux 16 line is telling it the exact name of the kernel file to load, that vmline use file. And right below it, you see that initram 16 line? It's pointing to something called an initram fs. And trust me, that little file is absolutely essential for the next leg of the race.
The baton is passed once again, and this time, it's going to the star player of the team, the absolute heart of the operating system, the Linux kernel. Everything up to this point has just been about getting this one piece of software ready to run.
So once it's loaded into memory, the kernel, which is actually a compressed file, unpacks itself and just explodes into action. It takes complete control of the CPU, it starts managing all the system memory, and it begins talking to all your hardware from a software level. This is the exact moment your computer truly becomes a Linux computer. Okay, but hold on. How can the kernel find your main hard drive if the drivers it needs to talk to that hard drive are on the hard drive, right? It's a classic chicken and egg problem. And the answer is the initram this. It's like a tiny little emergency toolkit that GRUB loads into memory with the kernel. It has just the bare essentials, like storage drivers, so the kernel has what it needs to find and access the real file system. And this right here leads to one of the most famous, or maybe infamous, errors in the Linux world. If that little initramfs toolkit is missing the one specific driver for your hard drive, the kernel wakes up, looks for its home, and can't find it. So it does the only thing it can do. It panics. It just stops everything because it literally has nowhere to go. All right, we're on the final leg of the race. The kernel has set up all the low-level stuff. Now it needs to pass the baton one last time to a process that will actually build the environment you and I interact with. This is the anchor leg, and it's run by systemd. So the very first thing the kernel starts is systemd. It's so special it gets process ID number 1. You can think of systemd as the general manager for the whole system. Its job is to start everything else you need, your networking, your sound, your graphical desktop, and to make sure it all starts in the right order. So where is systemd trying to get to? It's always working towards what's called a target. Now, this is just the modern name for what we used to call run levels. If you're on a server, you're probably heading for the multi-user.target, which is a full command line system. If you're on a desktop, the goal is the graphical.target, which brings up your entire graphical user interface. And man, systemd is fast. Instead of slowly starting things one by one, it's smart. It figures out what can be started at the same time and launches them in parallel. This is a huge reason why modern Linux systems can boot up in just a few seconds. It's a mad dash to get everything running and get you to that finish line, the login prompt. Okay, so now that we know the entire sequence of the race, from start to finish, we have a massive advantage. Because when something goes wrong, when a runner drops that baton, we'll know exactly where to start looking just based on what we see on the screen. And this table just lays it all out, doesn't it? If your computer stops at a grub prompt, well, you know the problem is with runner number 2. If you get that big kernel panic error, you know the issue is with runner number 3 and that init ramfis toolkit. And if the whole system boots up fine, but you can't connect to the internet, that's a problem with the final runner, systemd. Every error is a giant road sign pointing you to a specific stage of the race. And really, that's the whole point. This boot sequence isn't just some random trivia. It's a logical map of your system. Once you understand that flow, you're not just a user anymore, blindly hoping things work. You become a system detective, able to figure out what went wrong and why. So there you have it. That's the whole race, in just a few minutes. We went from a simple hardware check, to a bootloader, to the kernel waking up, and finally to all of your services launching. It's a perfectly executed relay, turning a dead machine into a live system, all in the time it takes to grab a sip of coffee. And the most amazing part? Your computer runs this entire complex, lightning-fast race every single time you push that power button, without fail. It's an incredible piece of engineering that most of us never even notice. But now you know exactly how it wins.